Hello everyone, I am Goklavashni, Assistant Professor in the Department of Food Technology. So welcome to today's session, the history and application of food sensors. In this session, we will trace the evolution of food sensors from their early manual beginning to the smart AI-driven system used today. You will see how these tools have become essential in maintaining the food quality, safety and sustainability. Let us begin by understanding why food sensors matters. Food sensors are the device designed to detect physical, chemical, or biological changes in food. These changes could relate to spoilage, contamination, temperature variation, or chemical adulteration. So, why do they matter? So, first, for food safety, each year millions fail ill due to contaminated food. So, sensors can catch problems before food reaches the consumers. And second, for waste reduction, they help extend the shelf life by monitoring the freshness. And finally, the quality control, ensuring that each batch of food meets set standards. They also enhance the supply chain, optimization processing, and even protects the brand reputation by preventing the recalls. And let us go back to the early days before electronics. In ancient times and well into the 1800s, people relied on the sensory evaluation, looking, smell, and tasting food to judge the freshness. So the basic chemical tests came later, like litmus paper or to test the acidity. Microscopy became important after the Louis Pasteur work in 1860s, where he studied spoilage microbes during the fermentation process. And manual thermometers were introduced in cold storage, helping to prevent the spoilage with proper temperature monitoring. So this simple method laid the foundation for the modern sensing technologies. And by the mid of 20th century, we started to see the use of electronic sensors in food processing. So the pH meter became the common in dairy and fermentation industries to control the acidity. The temperature probes like thermistors and thermocouple help the monitor precise the temperature during the pasteurization and storage. Conductivity sensors measured salt content in pickles or soups. So photometric sensors or simple calorimeters which used to just the ripeness or concentration by analyzing the color changes. So these technologies brought objectivity and reproducibility, taking food safety beyond human perceptions. So here, this period marked the digital revolution in sensory technologies. With microprocessors, sensors became portable, automated, and smarter. The concept of electronic nose and tongue was introduced, and the device capable of mimicking the human smell and taste to assess the flavor and aroma. NIR spectroscopy, that is near infrared spectroscopy, became a game changer, allowing non-destructive analysis of fat, moisture and protein. Gas sensors were now available to monitor oxygen and carbon dioxide level inside modified atmosphere packaging used to preserve the food. And this embarked a significant leap towards the automation and real-time monitoring. So next, welcome to the present. Smart and intelligent sensors have taken over food monitoring. Let us look at the key innovations. Biosensors, these detect pathogens or allergens in a minute, unlike older method and took days. Nanosensors, they offer the enhanced sensitivity, detecting even trace level of contaminants like pesticides. Hyper spectral imaging allows the scanning of food surface for bruises, ripeness or even internal defects. So wireless and IoT sensors can stream real-time data from farmers, factories or even real shelves, enabling remote control and traceability. Sensors today don't judge, monitor, they communicate, analyze and even predict. So let us explore how these advanced sensors are being used in food safety and quality control. So for pathogen detection, biosensors can now give results in less than 4 hours, helping the industry to reduce the product recall by 15% or more. And adulteration check, spectroscopic sensors verify the food authenticity. For example, checking whether honey is pure or adulterated is done. And the quality assurance, hyperspectral image can spot the bruised apples or tiny spots in rice during packaging. Freshness monitoring, in this the gas sensor like the ammonia or sulfur compound signaling the spoilage. So together they can help the companies meet the food safety standards and maintain brand trust. So now let us move to the supply chain and processing optimization. So RFID and temperature loggers together help to track the cold chain logistic, ensuring the frozen or chilled items stay within the safe limit. So sensors embedded in baking ovens or fermentation tanks help maintain the consistent quality, improving process repeatability by over 30%. Weight and moisture sensor in silos prevent the spoilage in raw material storage. In logistics, real-time sensors data reduces loss during transport and helps optimize the routes, saving the time and fuel. So this level of monitoring wasn't possible 2 decades ago, and it's now essential in modern food packaging system. So next up, smart packaging and how consumers can also benefit directly from the sensor technologies. The time temperature indicators or visual strips or stickers that changes the color if the product has been exposed to unsafe temperature, and freshness sensors smell the indicator embedded in the packaging that detects the gas like ethylene or ammonia, and in the traceability, QR codes or NFC tags allows the consumer to scan and view a product history, and also the farming practices, time transit, processing, etc., often supported by blockchain technology. And personalized nutrition, a future trend which will be coming in the upcoming days, is this the image sensor in your fridge or phone that can scan your food and tell you if it's suitable for your daily needs or allergies. So these innovation bring transparency and trust from the producer to consumer. And on concluding, sensors have become the nervous system of the modern food industry. So looking ahead, we will have even more AI-powered sensors, quantum sensors, and even edible sensors for health monitoring. Sensors will become the smaller, cheaper, and more autonomous, making them accessible even for small-scale industries. So they are no longer optional; they are essential for creating a safer, higher quality, and sustainable food systems. So whether you work in a food production, quality control, or R&D, understanding sensor technology is your competitive edge. Thank you. We shall meet in our next presentation.